All right, this is Mr. Ainsworth, and we're going to get into your homework problem on the growth function here. This is going with my lesson 4, all right, E4, when I taught base 2, an exponential growth function with base 2. Now your homework is base 3, all right, similar things. So refer back to E4 lesson, and on the preceding page, get your calculator out, your TI-84, and also a piece of scratch paper because we're probably going to have to do some arithmetic. So if you don't like using the margins, well, get a piece of paper out, pause the video, get it out, and work on the side if you like to write big. All right, so strap on your seatbelts. Here we go. And remember, it's a video, so if you want to slow me down, pause and play throughout the video. Okay, so the very first thing is we need to pick an appropriate domain, all right, for the growth function here. As we found in my previous lesson, the domain for 2 to the x was all reals. And so we can take 3 to any power we would like to. All right, so let's go from -3 to 3. So let's just set these values up here. And again, once use a margin or another piece of paper to do your arithmetic. All right, 3 to the -3 power is 1 over 3 cubed, which is 1/27. 3 to the -2 power is 1 over 3 squared, or 1/9. 3 to the -1 power is 1 divided by 3, or 1/3. 3 to the 0 power is just 1. 3 to the first power is 3. 3 squared is 9. 3 cubed is 27. And I know I went pretty fast, but again, this is base 3 using powers of 3, which we're really familiar with. All right, because we've done it so many times before. And we've done the drills, so doing this right here without a calculator should be easy for you guys by now. Again, we're analyzing y equals 3 to the x. Y equals 3 to the x. What does this growth function, when the base is bigger than 1, look like? And how does it act? And as you can tell, as x increases here, as x increases, y does too. From 1 to 3 to 9 to 27, it increases quite fast, actually. So let's go ahead and graph these like we always do here. 5, 10, 15. 20, 25, 30. There's -5, there's -10, 5 here, and 10. There's the scaling the axis, x-axis here, y-axis way above here. All right, and notice also right here, 0, 1, y-intercept. So you have the y-intercept there. We already know what that is, 0, 1. All right, so let's start our graphing here. -3, 1/27. Let's go left 3 up just a teeny bit. So close to the axis you can't even get that close. All right, left 2 up a 9th, left 2 up a 9th, left 1 up a 3rd, and 0, 1 right there. There's your y-intercept right there. 1, 3, and 2, 9. No, right there. 3, 27. So that's 3, 27. And this is 2, 9, and this one is 1, 3. All right, go ahead and sketch your function through those points. Oh, missed it. Let me redo that. Use a pencil when you do this. Put sound effects in. Takes off. Let me highlight these points. Make them bigger so you can see them better. All right, and it's asymptotic to the x-axis. So let's highlight that in through here. It's asymptotic to the x-axis. Has an equation y equals 0, just like the last one. 3 to the x has the same asymptote. It's a, whoops, I put that in the range. I got to put that in the horizontal asymptote spot, which is right here. I use HA for horizontal asymptote. So this is it right here. Okay, it's that x-axis. The curve gets really, really close to that. In fact, you know what? Let me show you something. This is a cool program I have that shows you what's going on really well, much better than your graphing calculator, although we do it with yours too. I'm going to type in y to the 3 to the x. So here we go. Y to the 3. Ooh, not s, but how about 3? And let me get my calculator keypad out. Let's take it to the x power. All right, and let's graph this function. And let me zoom out. So notice here, if we trace along the function here, okay, there we go. All right, so we trace along the function. There is the y-intercept y equals 1. It gets smaller and smaller and smaller. Oh, let me zoom back. Let me zoom out here. Whoop, let me zoom in. Excuse me, this is zooming out. Okay, there we go. All right, the y values get extremely small. Look right up here. Here are the coordinates of my cursor right here. When x is negative 3.75, y is 0.01, which is super small. And it gets super small. Never gets 0 because it's impossible to take 3 to a power and get negative numbers. All right, they're always positive, and that's why this graph is above the x-axis. That's why the range is greater than 0. Okay, so in fact, let's write that down. The range is y greater than 0, just like the last one. All right, these exponential functions like this, without being translated, are all greater than 0. The x-intercept doesn't have any, all right, because it doesn't cross the x-axis. Doesn't cross the x-axis. That's an important point right there. And if it doesn't cross the x-axis, it can't have an x-intercept, guys. It's impossible. X-intercepts are where the function crosses the axis. It has a y-intercept because it crosses the y-axis, but it doesn't have an x-intercept. So remember that. On your calculator, you're going to hit y equals, and you're going to go 3 to the power of x, and adjust the window before you do that. I used this calculator before, and I had to reset it, the y max to 300. Right, I want to reset it to 30, all right, so I can see things better. And there we go. And the reason why I can't see the left side is because I need to set it to -5. And let's set that to 5, x max. X max is around 5. Biggest x value in the table is 3, so let's make it 5. And then hit the graph button, and there you go. There's the same curve. Now, if you want to go zoom 5, it will square it out so the axes are the same. And now the axes are the same. You see these tick marks on the horizontal and the vertical? Now they're the same. So Z5 squares it out so the axes are the same scale. One's this way, one's this way. And look at the curve. Look how fast it goes up. Boom. Just like this one. All right. It takes off exponentially. I mean, that's why we call these exponential functions, is because they increase very, very fast. All right. Now let's take a look at the next one. Let's figure out, what does this +1 do to the function right here? And I'm talking about the +1 right there. What does this do to the parent function? Parent function, we're talking about 3 to the x. What does it do? Well, we know what it did last time, so if you want to go back a page, take a look at what the question was and and what it did here. And take a look. Let's go back up here. What kind of effect did it have when we did 2 to the power of x plus 1? We found it was a vertical shift up. Well, what the heck, man? We should learn from prior experience here, and we should expect the same thing. All right, it's just going to be a little bit steeper because we have base 3, which increases faster than a base 2. All right, so here we go. We're going to enter in values from -3 to +3. So -1, 0, 1, 2, 3. We do it all by hand first. So -3, or 3 to the -3 power. This is where you want to do your side work, by the way, and get out a piece of paper here. So pause the video, get paper out, because I don't think the margin is going to be enough for you. So 3 raised to the -3 power plus 1. That's 1 over 3 cubed plus 1. That's 1/27th plus 1, which is 1 and 1/27th. So 1 and 1/27th. 3 to the -2 plus 1 is 1/9 plus 1, which is 1 1/9. So 1 and 1/9. Remember, this is a video, so if I go too slow, pause, and then play whenever you need to, okay? This is a video, so take advantage of it. All right, 3 to the -1 plus 1 is 1/3 plus 1, or 1 1/3. Let me write that better. 1 1/3. Got to think simple. So 1 1/3 here. 3 to the 0 power is 1 plus 1 is 2. Well, 3 to the 1 is 1. Excuse me. 3 to the first power is 3 plus 1 is 4. 3 squared is 9 plus 1 is 10. 3 cubed is 27 plus 1 is 28. And if you compare these values, look at this. 2, 9 became 2, 10. 3, 27 became 3, 28. The y values are increased by 1, and that's why this thing shifts up 1. Shifts up 1 unit. All right, it's a vertical shift. How about that? It's just like the last one. All right, so a couple things change. We'll note that when we do it. So we have 5, 10, 15, 20, 25, 30. We have 5 here, 10 here, negative 5 here, negative 10 here. And we start graphing, we start going for it. So negative 3, left 3, up 1 and 1/27th. So left 3, right there, up 1 and a teeny bit more. Left 2, up 1 and 1/9, a little bit above it. Up left 1, up 1 1/3, 0, 2. There's your y-intercept right here. All right, and then 1, 4 is right there. 2, 10 right there. 3, 28 way up here. There's 328. There is 2, 10. All right, and this is 1, 4 right here. So I even label my points for you. All right, so now you graph this function here, and it takes off exponentially upward here. All right, now there's a gap there. There's the horizontal asymptote. Oh, guess what? Y = 0. That's been shifted up too. Let me show you on my other program here. If I add 1 to this function here, watch what happens. If I add 1 and I regraph it, notice it flattens out, okay? And the y values, get your eyes right here. It's 1.39 right now. Watch what happens. No, it's flattening out. They're getting really close, and then guess what? 1.00003. That's approximately close to 1. It'll never actually hit 1, but it's going to get infinitely close to 1. Not only that, watch this. If I plot a new function here, so I can show you the asymptote in red, y = 1, and regraph. Look at this. There it is. The horizontal asymptote y = 1. It's been shifted up 1, just like every other point. And like I said, these y values are approaching 1. And that's why it has a horizontal asymptote at 1. All right, so let's record that. And get out your red pen, and let's draw that horizontal asymptote in red. So y = 1 here. Let's label that HA for horizontal asymptote. It's not supposed to be jagged. My fingers moved right there, and it doesn't go below that line. It's asymptotic. It just gets really close. So the horizontal asymptote, put that in red. Y = 1 as compared to y = 0 because it's been shifted up 1 unit. Remember that? Okay, it's been shifted up 1 unit. And let me see, x-intercept doesn't have one because it doesn't cross the x-axis. Domain, same thing, all reals. And range, ooh, now this is different. Now over here they're greater than 0 because they're above the x-axis. Now all these y values, they're all bigger than 1. Bigger than 1. All right, the big number 1. So now my range is y greater than, not greater than equal to, y greater than, come on, Ainsworth, y greater than 1. All right, because they're all above 1. Notice that 1, 1/27, well, that's bigger than 1. All of them are. I don't care how far left you go. It will always be bigger than 1. Okay, moving on. What would happen if we subtract 1 from the parent, and what would happen if we add 5? Okay, what kind of effect does this have? Well, let me see. Let's use our common sense a little bit. Up here, the plus 1 shifts it up 1. What do you think the minus 1 is going to do? You know, say it out loud if you're by yourself, or tell your partner. Okay, you got it. It's a downshift 1. It's a vertical shift down 1 unit. Vertical, all right, shift, all right, down 1 unit. And we're going to see that after we graph this. Okay, so here we go. Remember, do your side work either in the margin or in another piece of paper, because this one's a little bit more intense. All right. Well, actually, no, I take that back. It's not bad. So -3, -2, -1, 0, 1, 2, and 3. Okay. Substitute them in. So we get 3 to the -3 minus 1. That's 1/27 minus 1. That's equal to a negative number now, so -26 27ths. So -26 27ths. Not quite -1, is it? Next one, 3 to -2 minus 1, that's 1/9 minus 1, and that's negative 8/9. Negative 8/9. Next one, 3 to the negative 1 minus 1 is 1/3 minus 1, or negative 2/3. Now, if you're not as fast at the arithmetic, like I said, pause the video, keep on pausing. You can even pause before I do it, and do it on your own, and then play it, and then check your values. All right, you got to learn how to use the technology. All right, 3 to the 0 power minus 1 is 1 minus 1, or 0. So you got 0, 0 there. Believe it or not, it goes through the origin. There's your x and y intercepts there. All right, and then 3 to the first minus 1 is 3 minus 1, or 2. So you got 2 there. And 3 squared minus 1 is 9 minus 1, or 8. 8 here, and then 3 cubed minus 1, that's 27 minus 1, or 26. So you have 26 here. So once again, you plot and you learn from your work, all right? And that's what investigating mathematical functions is all about, all right? You do it, and you investigate it, and you learn from it. That's why we do this by hand. And then we back it up with the calculator. All right, so here we go. We plot negative 3 down 26, 27, so which is not down 1, it's down, just almost down to 1. So left 3, down, almost down to 1. And then left 2, almost down to 1. And then left 1, down 2/3. And then hits the origin. And then 1 comma 2 is right here. And 2 comma 8 right here. And 3 comma 6 way up here. All right, so this function looks like this. Whoa, missed it. There we go. Let me highlight the points I made. Okay, so now it crosses and goes below the x-axis because, again, everything gets shifted down. So our parent function has a horizontal asymptote at y equals 0. Well, it's been shifted down. All right, so our horizontal asymptote is now y equals 1. Y equals 1. And let me label that over here so we don't interfere with the next problem. And so our horizontal asymptote has been shifted down here. Our y-intercept is 0, 0. X-intercept 0, 0. Domain all reals again. Okay, that hasn't changed. The range, that has changed. All these values are bigger than negative 1 now because we dropped this function down a unit. So they're all greater than negative 1. So the range changes. Look at all these values. They're all greater than negative 1. Can't say greater than 0 because these negative numbers aren't. Okay, but they are greater than negative 1 because it's been shifted down at 1 unit. So remember that. Okay, and the last function that we have to do is 3 to the x plus 5, and we expect that to be an upshift. Okay, 5 units, upshift 5 units. That's what we expect by learning from last lesson and this lesson. So let's see if it happens here. Oh, I forgot. Let's graph this baby. So go to this right here, go to the right, and let's go -1. Graph that, and there it is. See it dip below the axis right there. Let's check the domain. Minimum, set y minimum down to -3 so we can see more. And x max or x minimum, set it to -5 so we can see a better picture. 5 here for x max. Y minimum down to -2. -2 would be good. Y max 30 is good. Graph. There we go. That's a better look. Okay, so it goes below the x-axis. Not only that, let me show you this right here. Oh, let's change it to -1, and let's regraph. And let's change this down here. Let's change this function to -1 and regraph that. Oops. There we go. So you can see what's going on here. The function's it's increasing function here from left to right. All right, but as you can tell, it's asymptotic to y equals -1 because there's y equals -1 right there. Get your eyes on the y values right here. So as I go to the left, these y coordinates are getting close to -1. Not exactly equal to -1, but getting close to -1. Okay, So we got that. The only thing we need to do is the next one. All right, here we go. So let's set up the domain. Let's substitute some values in. So 3 to negative 3 plus 5 is 1/27th plus 5, which is 5 and 1/27th. 5 and 1/27th. 3 to the negative 2 plus 5 is 1/9 plus 5, or 5 and 1/9. 5 and 1/9. 3 to the negative 1 plus 5 is 1/3 plus 5, or 5 and 1/3. 3 to the 0 plus 5 is 1 plus 5, or 6. So notice it went from, oh, this is a totally different function. Never mind, it was what I was going to say, 1. So 3 to the first plus 5 is 3 plus 5, or 8. 8 here. 3 squared plus 5 is 9 plus 5, 14. 14. 3 to the third plus 5 is 27 plus 5, 32. So 32. So you don't even need a calculator there. All right, so there you go there. And let's scale 5, 10, 15, 20, 25, 30. There's your y-axis, x-axis. There's 5 and there's 10, negative 5, negative 10. All right, here we go. Let's start plotting here. We got left 3 up 5 and a little bit. So left 3 up 5 and a little bit. Left 2 up 5 and a little bit. So left 2 up 5 and a little bit. Well, that's too high. Just a teeny bit. All right. Left 1 up 5 and a third. And 0, 6 y-intercept right here. There it is right there. 1, 8 right there. 2, 14 right there. 3, 32. Oh, not high enough. 3 up 32. There you go. There's 3, 32. All right. So now we have our function that looks like this. All right. So let me highlight these points. I plotted that one, and 1, 8. That one. 2, 14, that one, that one, that one, that one, that one, that one. There we go. And the asymptote's changed too. Guess what? It's an upshift. All right. Everything's been shifted up. All right. Everything's, including the horizontal asymptote at y equals 5. So remember that. Expect that. All right. So then you can back that up with the calculator too. All right, all you have to do is change your values. Let's change this to 5. Let's change this to plus 5. There we go. I didn't type it in right, so let me redo that. 3 to the x power, and then add 5. All right, now hit go. There we go. Let me zoom out. There we go. So there you go. There's your y-intercept right there at 0, 6. Right there. Okay, and then it gets closer and closer to 6. Excuse me, it's closer and closer to 5. Look at that, y equals 5. All right. And if you want to do it on your own calculator, be my guest. All right, so there we go. We don't have an x-intercept here, so there are none because it doesn't cross the x-axis. The domain is the set of all reals again. You can take 3 to any power you want. Range, greater than 5 now. Y is greater than 5. So what's the relationship overall? Here's the basic idea. As x increases, okay, as x increases, y increases exponentially. Increases exponentially. Exponentially. All right? It really goes up. X goes up, y really goes up. I mean, it really takes off fast. Okay? There's your homework on the first one there. And I'll see you in the next lesson on where the base is less than 1, like 1/2, and and we'll go for a new exponential. See you then. This is Mr. Ainsworth signing off. See you in my next lesson.